if you're watching this, this is the solution to problem number 1 with the displacement and time graph. The key here is to know that the slope of this graph really tells us everything we need to know. The x-axis really doesn't tell us much. It just tells us wherever the measurement tool starts measuring from. This object starts at wherever our measurement tool is, meaning like a ruler or whatever we're calling 0. And then it walks away in the positive direction, and then it stops here, and then goes backwards. And even though it's crossing right here, that doesn't mean it stopped, because we look at the slope. So the slope of this on here tells us the velocity, which is speed with direction. So where's the object stopped? The only place it's stopped on here is where the slope is 0, so it should be right here. So if we look on here, there's some answers that make sense. Definitely not 5. 5's right here. 12, this is 15, this is 10. 12 would be in between. It would be stopped at 12. Okay, so I'd want to select 12. 21, it's moving. 30, it's moving because the slope is not 0. And all those, well, the only place it's moving, it's not moving, is 12. So everything else is going to be moving. So 12 is the only answer I would select there, since we're checking all that applies. When is the object moving backwards? Well, you can tell where the object is moving backwards by simply, again, looking where the slopes are negative. And that happens between 15 and 40, because the tangent lines here, if you draw them, there's a tangent line, there's a tangent, they're always facing down, which means it's going backwards. So if I'm looking, I need it to be between 15 and 40, so I'm going to select all the ones between 15 and 40. We'd want to select all those. How fast is the object moving at time 5? So let's go to time 5 here. All right. Time 5 is right here. So I need to find the slope at 5 seconds. Okay, so in order to do that, I could just draw a tangent line, and you notice my tangent line nicely actually just matches that blue line anyway. So I need to find the rise and the run of this. The run is 0 to 10, so that'd be 10 seconds as my run. And my rise right here will be from 0 to 60, so that's 60 meters when I do my rise and run. 60 meters divided by 10, let's make it in green, 10 seconds equals 6 meters per second. And I would want to include my units on the quiz if you're retaking it, but not on the form, so because it messes with the formatting and the auto grade. So the answer would be 6. On the quiz, it would be 6 meters per second, because it should give you points for the units.